Assalamualaikum. My name is Muhammad Suhaili bin Bakri, metric number AP1900418. Okay, today we're gonna talk about soil identification. Okay, soil can be identified through its physical properties, including texture, surface area, structure, and plasticity. Okay, first we're gonna talk about soil texture. Okay, soil texture is a classification instrument used in the field and laboratory to determine soil classes based on their physical texture. Soil texture can be determined using quantitative methods such as texture by feel and quantitative methods such as the hydrometer method. Next, we're gonna talk about soil surface area. Okay, soil surface area is the specific surface area of soils, and soils constitute is typically expressed as surface area per unit mass of soil in units of square meters per kilogram. The specific surface area of soils and soil constitutes can range from less 1 times 103 meter square kilogram. Okay, after that we're gonna talk about soil structure. Okay, soil structure describes the arrangement of the solid parts of the soil or the pore space located between them. It is determined by how individual soil granules clump, bind together, and aggregate, resulting in the arrangement of soil pores between them. Next, we're gonna talk about what is soil plasticity. Okay, plasticity of the soil is defined as its property by virtue which it undergo deformation without cracking, fracturing, or rupturing. Okay, plasticity is due to the presence of minerals surrounding the soil solids and water present in absorbed layer of the soil solids.
Hi, I'm Yao Xuexin and my metric number is AP190136. Today I would like to talk about understanding grain size distributions. In soil mechanics, it is usually always useful to quantify the size of the grains in a type of soil. Since a given soil will often be made up of grains of many different sizes.
Now here is a table that labels all of the particle sizes. The particle size of clay is 0.002 milliliter and below. For fine silt is between 0.002 milliliter and 0.006 milliliter. Medium silt is between 0.006 milliliter and 0.02 milliliter. For coarse silt is between 0.02 milliliter and 0.06 milliliter. For sand, fine sand is between 0.06 milliliter and 0.2 milliliter. Medium sand is between 0.2 until 0.6 milliliter. For coarse sand is between 0.6 until 2 milliliter. For the particle size of the gravel, fine gravel is from 2 milliliter until 6 milliliter and medium gravel is from 6 milliliter until 20 milliliter. For the coarse gravel is from 20 milliliter until 60 milliliter. For the cobbles, the size of the particles is from 60 milliliter until 200 milliliters. For the boulders is from 200 milliliters and above.
Sizes are measured in terms of grain size distributions. Grain size distribution information can be a value in providing initial rough estimate of a soil's engineering properties, such as permeability, strength, expansivity, and so on. A subject of active research interest today is the accurate predictions of soil properties based largely on grain size distributions, void ratios, and soil particles characteristics. When measuring grain size distributions, two methods are generally used. First, sieving. Sieving is used for grains larger than 0.075 milliliter. Secondly, hydrometer test. The hydrometer test is used for the grains larger than 0.5 micrometer and smaller than 0.075 milliliter. That's all for me. Thank you.
Hello, my name is Miklin Jebun bin Maiman and my metric number is AP190475. Today I will talk about grain size distribution. Grain size distribution, also known as gradation, refer to the proportion by dry mass of a soil distributed over specified particle size range. Gradation is used to classify soil for engineering and agricultural purpose, since particle size influence how fast or slow water or other fluid move through a soil. Next, I will show you a video about how to draw a grain size distribution curve.
The purpose of this video is to demonstrate how to create a semi-log plot for a grain size distribution plot. We'll start off, I have my data that I want to plot already in here. I have the grain size information and the percent finder by mass. So I'll select that data that I want to plot, go to the insert menu and select charts. And if I want them to be straight lines between each data point, I can select the scatter straight lines. If I want it to be a smooth line, I can select the scatter smooth lines. We can also select smooth or straight lines showing the data points. For this plot, I'm just going to select the smooth scatter with smooth lines. And now our chart is placed into our Excel spreadsheet. Currently, it's normal in both the X and Y axis. In order to make the X axis a log scale, I'm going to select that axis. I will double click on it. And you can see that a Format Axis menu comes up. And then I'll scroll down through there and we can see we'll get a logarithmic scale. So I can change that x-axis to a logarithmic scale. We can see that the y-axis right now is located where x is equal to 1. I can also change that location. You can see in this Format Axis menu, there's an axis value. I'll change that to 0.01. And that will change my y-axis to be crossing where x is equal to 0.01. Enter, and that is done. A couple of things we want to do before we're done with this plot is we do want to add axis titles. And by clicking that plus button by the chart and then putting the check mark by axis titles, the y and x axes show up. I can select the axis label and then just change the label. So I'll change that to percent finder by mass for the y-axis. And then I can select the x-axis title and change that to grain size. And the grain size in millimeters. And depending on what I'm doing, I may or may not have a chart title for this. I'm going to delete my chart title. Also, I may not want my y-axis to have a value greater than 100%. So I can go back, double click on my y-axis, and I can change the maximum value in the bounds section to 100. And there's my grain size distribution. One of the things I would want to do on this plot to help me when I'm starting to look at percent finder by mass for say a D30 or D60 is I would want to add some grid lines. Right now I only have grid lines at the major values on the x-axis, and so I'm going to when I select this menu here, I have the option to add grid lines along the minor vertical or minor horizontal. So if I select minor, I get these lines that show up in my plot. And so that'll be helpful for, again, determining the percent finer by mass at 30% or 60% or 10%. That, I hope, gives you enough information for you to be able to plot grain size distributions in a semi-log plot.
From the grain size distribution graph, you can classify the soil according to the nominal size. For example, the nominal size is 0.06 to 0.2, and you can know that that is a fine sand. Another example is 0.002 to 0.006, and you can know that is fine silt. That's all about grain distribution size from me. Thank you.
A very good morning to Dr. Hamidun and my friends. My name is Jasmine Lailokong, metric number AP190101. Today, I'm going to talk about plasticity.
Plasticity is a property that enables a soil to undergo deformation without breaking. This property is characteristic on fine-grained soils only, in the presence of water. When water is replaced by some other liquid, the clay will behave as granular mass. Plasticity is due to clay materials in the soils and is exhibited only over a specific range of moisture content. Excessive water turns the soil into suspension. With gradual decrease in the water content, the soil passes into plastic state and into a semi-plastic state, and finally into a solid state. Liquid limit is defined as the water content of soil change from liquid state to plastic state, and it is expressed as a percentage. It can be determined by Kaiser-Grande's apparatus or cone penetration test. Plastic limit is, at some water content, soil becomes plastic from liquid state when water is reduced. The next part is plasticity index. Plasticity index is the difference between the liquid limit and plastic limit of a soil. And here is the formula and description of plasticity index. The next part is liquidity index. The relative consistency of a cohesive soil in a natural state can be defined by a ratio. Here is the formula and the description of liquidity index. Swedish chemist and agricultural scientist Albert Atterbert mentioned that, depending on the water content, the consistency of fine-grained soil can be divided into 4 steps. The first one is liquid state. In this state, a soil containing high water content. It offers no shearing resistance. It can flow like liquid and it has no resistance to shear deformation. The next state is plastic state. At some water content, soil becomes plastic from liquid state. Water content is reduced. Soil in plastic state can be molded into various shapes. As water content is reduced, the plasticity of soil is also reduced. The third state is semi-solid state. When water content is reduced below plastic limit, soil attains a semi-solid state. The soil in this state cracks when molded. The volume of soil decreases in water content. The last state is shrinkage limit. The water content at which soil changes from semi-solid to solid state. It stops shrinking further and attains a constant volume. It is the lowest water content at which soil is fully saturated.
Miss Hazel Harrison, anak Stephen. My matrica number is CP190004, and today I would like to share about British Soil Classification System. The system is also known as the British Standard BS 5930, which is a code of practice for site investigation. For this system, it has divided soil into two parts, which is the coarse soil and also a fine soil. The amount of soil that passed through the 16.3 micron sieve is less than 35%, then it is considered a coarse soil. However, if the amount of soil that passed through the 16.3 micron sieve is more than 35%, then it is considered as fine soil. For the gravel, they are divided into three soil group, which is slightly silty or clayey gravel, silty gravel and clayey gravel, and very silty gravel and very clayey gravel, and they all have their own subgroups descriptions. As you can see in this sand table, the soil group are divided into three, which is slightly silty or clayey sand, silty and clayey sand, and also very silty and very clayey sand. And for the group description, you can refer to this table here. For the fine grained soil, they are divided into two, which is silt and clay. And for the silt, the subgroups are varies from silt of low plasticity to silt of extremely high plasticity. Same goes to clay, where the subgroups are varies from clays of low plasticity to clay of extremely high plasticity. Types of soil are designated by capital letters such as M for silt, C for clay, S for sand, G for gravel, O for organic soil, F for fine soil, and also PT for peat. Fine grained soils are represented by a point on the plasticity chart. As you can see in the table, the plasticity chart are divided into low plasticity, where the liquid limit is lower than 35, and upper plasticity zone, where the liquid limit is higher than 35. For the upper plasticity zone, they are subdivided into intermediate plasticity, where the liquid limit is in between 35 to 50, high plasticity, where the liquid limit is in between 50 to 70, very high plasticity, where the liquid limit is between 70 to 90, and extremely high plasticity, where the liquid limit is higher than 90. That is all from me, and thank you for listening.
Dear Doctor, my name is Ko Chi and my metric number is AP190171. Today, I will speak to you about the Unified Soil Classification System. Unified Soil Classification System most widely used to classify soil for use in foundation and dam engineering. There are four major divisions, which are coarse-grained soils, fine-grained soils, organic soils, and peat. The tests required for classification of soil are grain size analysis, liquid limit, and plastic limit.
Next, Unified Soil Classification System includes two broad categories, which is coarse-grained soils and fine-grained soils. Coarse-grained soils that are gravel and sand with less than 50% passing through the number 200 sieve and classified based on grain size distribution. Gravel is retained above number 4 sieve, which is larger than 4.75 mm sieve size. By using sieve analysis, Cu and Cc from grain size distribution. Cu is uniformity coefficient and Cc is coefficient of curvature. However, fine-grained soils that are silt and clay with 50% more passing through the number 200 sieve and classified based on plasticity chart. Silt and clay is finer than the number 200 sieve, which is 0.075 mm opening. By Albert limit result,
PL stands for plastic limit and LL stands for liquid limit. Liquid limit 50 or more is high plasticity, while liquid limit less than 50 is low plasticity. Next is called as group symbol. The first letter is based on mean soil type. The second letter is based on gradation and plasticity. G stands for gravel, S stands for sand. Gravel and sand is coarse grained soil, yet M is silt, C is clay, and O for organic. These three are fine grained soil. For the second letter, coarse grained soil is based on gradation, which is W stands for well graded soil and P for poorly graded soil. And for grained soil, fine grained soil is based on plasticity, which is H for high plasticity soil and L for low plasticity soil. The soil is classified into 15 groups: GW, GP, SW, SP less than 5% fines, and GM, GC, SM, and SC more than 12% fines. GW is well graded due to CU greater than 4 and CC between 1 and 3. Yet, SW is well graded sand due to CU greater than 6 and CC between 1 and 3. Lastly, for plasticity chart, there are silt, clay, and organic. Below A line, use M, which is silt, or O for organic. Above A line, use C, which is clay. For example, the soil liquid limit after oven drying is less than 75% of its liquid limit before oven drying. If the above statement is true, then it is organic soil, OL or OH. Otherwise, it is inorganic soil, ML or MH. When liquid limit and plastic limit are in the hash portions of the plasticity chart, the soil is given the symbol CL, ML.
Well, that's all for today. Thank you for listening.